Hi, we are going to see about CPU scheduling. CPU scheduling, here there are four types of scheduling. In that, the first one is first in, first out. Here, first in, first out means whatever the process comes first is being executed. The second one is executed second. There is no order assigned here. Whatever comes first, it's been executed. Second type is shortest job first. Shortest job one, if there are 4 or 5 process, from that 4 or 5 which has the least execution time is taken first for process. Thus there will be, even though if the least thing is on the process 5, it will be taken first for execution. Third one is priority scheduling. Priority scheduling in the sense, here the which one has to be executed first, second, third, the order will be given. On that basis only we are going to take it for execution. Fourth one is round robin. Round robin in the sense, a particular time quantum will be given. For particular time only the first process, if first process is taken first and it is executed, and after the completion of that time the second process will be taken. For example, if the time quantum given is 3 seconds, process 1 is executed only for 3 seconds. After 3 seconds, the process 2 is taken. After 6 seconds, that means the completion of that 3 seconds time quantum, third process will be taken. So all the process is executed, and if the first process is not completed the entirely, then the first process gets executed again. So it's keep on going until the burst time of those process gets completed. Here we are going to see about first in, first out CPU scheduling. Here there are two types. One is preemptive and non-preemptive. Now we are going to discuss about non-preemptive only. Preemptive in the sense, when the process is executing, even though if it is not completed its task, we can stop it and we can execute which we need to do. So it can be stated, it not only we have to wait for completion of this particular process. Non-preemptive means once the process entered, it gets completed entirely and then only the next process is taken for execution. Here we have to find NOT chart, waiting time and turnaround time. NAT chart in the sense, all the process which are taken here, there are 5 process. From this process we are going to represent the NAT chart. That is, first initially here, in some situation the waiting time will be given. Here the waiting time is nothing is given, so we have to consider, while taking the process 1 to execution there is no waiting time and it is 0. Next we have to, process 1 takes 8 seconds to complete, so after 8 seconds it will get completed. So the NAT chart for this is P1 starts at 0 second and complete at 8 second. Next, the next process P2 is taken and its burst time is 4. So P1 takes 4 time for execution. So P2 starts at 8 seconds and it has to take 4 seconds for entirely complete. So after 8 plus 4, that is 12. P2 completes at 12. Next one is P3. So P3 and its burst time is 5. So P3 starts after 12 seconds, that is from 13 second, and it gets complete at 17 seconds. So next one is P4. P4 takes 2 seconds. So it gets completed at 19. Final one is P5. It takes 1 second and P5 completed 20 seconds. This is our NAT chart. That is, there is no waiting time given, so it starts at 0. P1 has burst time of 8 seconds to complete its task. So P1 starts at 0 and ends at 8. P2 starts at 8 after P1 completes at 8 seconds, so P2 will be starting from 9 and it gets completed at 12. Like that, how much burst time is given, we have to represent. Next, we have to find the waiting time. Waiting time in the sense how much the process is being waited. So here it's the process P1, P2, P3, P4 and P5. So we initially P1 does not wait for any completion, so it is 0. Here this is 0 and we have to check whether there is any other process gets completed. So no, it initially starts with 0. If there is any other seconds here, it has to be mentioned. So nothing, so that is waiting time of P1 is 0. Next P2 starts at 8 and initial waiting time is also 0, so 8. P3 starts at 12 and initial waiting time is 0, so 12. 17 minus 0, 17, 19 minus 0, 19. So from P1 that does not wait anymore, so 0 and initial waiting time will be same, so 0. For P2, 8 minus 0, 12, for P3, 12 minus 0, P4, 17 minus 0, P5, 17 minus 0. So this is our waiting time for each process. Here we have to find the average waiting time. So for finding average waiting time, we have to sum all this waiting time value and divided by number of processes. So 1, 2, 3, 4, 5. So the value is 20, 37, 56 by 5. So average waiting time is 11.2. Okay, so the average waiting time for this FIFO is 11.2 seconds. Next we have to find the turnaround time. Turnaround time is similar, but only thing is P1, P2, P3, P4 and P5. So turnaround time is calculated by waiting time plus burst time. So waiting time plus burst time. So P1 waiting time is 0, P2 waiting time is 8, P3 waiting time is 12, 17 and 19. Next, the burst time is the time taken from each process. So for P1 the waiting time burst time is 8, P2 4, for P3 5, P4 2 and 1. So the values are 8, 12, 17, 19 and 20. This is our turnaround time for each process. Next we have to find the average turnaround time. Average turnaround time is, we have to sum of these all turnaround time and find the value. So 8 plus 12 plus 17 plus 19 plus 20 divided by the number of processes 5. So the values are 20, same, extra the 20 is added, so 76, 50, yeah, divided by 5. So that is 15.2. So for the given process, the average waiting time is 11.2 seconds and for turnaround time is 15.2. First and main thing is the nut chart has to be found. If initially if there is any waiting time given, it has to be specified. If not, we can start it with 8 and keep on going by adding each burst time. Next 5, I have to find the waiting time. how much the process is waiting for going to the execution stage, and find the average waiting time. Turnaround time is simply equal, that is we have to sum of waiting time plus burst time and find the average turnaround time. Okay, thank you.